We're going to spend the next couple days looking at how everything that we've learned in this chapter for quadratics fits into word problems or real world problems that you would want to solve. So in today's lesson, we're just going to look at a couple sample word problems, and then we'll do a review of the different methods of solving quadratics. So the first word problem, Jocelyn and Kelly built rockets from assembly kits and are going to launch them at the same time to see whose rocket flies higher. If Jocelyn's rocket's height in feet can be described by this equation, negative 16x squared plus 180x, while Kelly's is represented by this function k of x equals, it should be negative 16x squared plus 240x. Who wins the rocket race? What is the max height for both rockets? After how many seconds does each rocket land? So again, here's the equation. The negative 16 is the downwards acceleration in feet per second. The 180 would be the velocity. And since there's no other value, it means that they start at a height of 0. And then Kelly's function, again, should be negative 16x squared for the downwards acceleration. 240 would be the velocity, which is, you can see, higher than 180. All right, so again, we want to see whose rocket flies higher. You can kind of take a guess. I mean, Kelly has a higher velocity, but we'll use math to double check. So to do that, we're trying to think for the height. So you're thinking about the graph of this right here, the height. When you're solving the quadratic, we have, different parts of the quadratic. So if we draw an example of one, we know how to find the zeros, and we know how to find the vertex. So to find the max height, we would be looking at the vertex for each of these. So let's do Jocelyn's first, and remember, to find the vertex, you could graph it and find the vertex. You could use factoring to find the zeros and then go in the middle to find the vertex, or we could use quadratic formula, and again, to find the middle of this right here, we would use that negative b over 2a. So I think I'm going to use that method, probably the quickest. All right, so for Kelly, we're going to use that negative b over 2a to find the x value of her height. And again, this is height, and this would be time. So we're looking for the time here, and then we're going to find the height at the time that it reaches the vertex. So right here, if we look at our equation, negative b is 180, negative 180, over 2a, and that would be 2 times negative 16. So if we do negative 180 over negative 32, we're going to get 5.625 seconds. Okay, so Kelly, actually this is Jocelyn I was looking at, not Kelly. So Jocelyn, it takes her rocket 5.625 seconds to reach the max height, but we need the actual height. So let's plug into the function to find the height. So I'll use a different color here. So her height, Jocelyn's height at 5.625 would be negative 16 times 5.625 squared plus 180 times 5.625. Okay, so we're just plugging into our function with the height. And if you do that, you should get 506.25 feet. If I did that correctly. Hopefully I did. Okay, so there is Jocelyn's height at her vertex. Let's do the same thing for Kelly. Now I'm going to need more room here. So for Kelly, again, we're going to use that negative b over 2a to figure out the time. So this is her time. So let's look at her b value. It is 240, negative 240, over 2 times negative 16. And if you calculate that, you'll get 7.5. Okay, so hers reaches her max height at 7.5. It takes longer. It doesn't get higher. So we're going to plug into our function. K of 7.5 would be negative 16 times 7.5 squared plus 240 times 7.5. And yes, it will be higher. Her rocket reaches a maximum height of 900 feet. All right, so Kelly's rocket will be higher. We could have guessed that because her acceleration is faster. So we would say Kelly, with a height of 900 versus 506.25 feet. After how many seconds does each rocket land? Well, we have this time right here to get halfway, to get, if I'm graphing this right here, we figured out the time for the vertex, which is halfway up. So if we double that, it would tell us how long it takes to hit the ground. So for Kelly, or for Jocelyn, to find the time it takes to hit the ground, we're going to double the 5.625. So if we do that, let's multiply that by 2. 5.625 times 2, 11.25. So there's Jocelyn, 11.25 seconds. And for Kelly, hers took 7.5 seconds. So if we multiply 7.5 times 2, we'll get 15 seconds to hit the ground, or to land. To the nearest tenth of a second, what was the difference in time for the two rockets to reach their respective max heights? Okay, so max heights, we would do 7.5 for Kelly, minus 5.625 for Jocelyn, and that would be 1.875. So 1.875 seconds would be the difference in their times. Okay, so there's the first problem right there. Let's do a few more. Let's see which ones I selected, a few of them. Okay, this one is very similar. The height h in feet of an object above the ground is given by this function. So this function starts 190 feet above the ground. There's the downward acceleration. Here's the initial velocity, 64. Find the time it takes the object to strike the ground. So there's a few ways to do this. Again, you can think about what you're looking for. Here's the situation. Okay, so you'll find two zeros. And here are the two zeros you're looking for. And remember, we've learned several ways. You could factor, set it equal to 0 and solve. You could use quadratic formula, which is the method that I would use, quadratic formula. And again, you'd have two answers, but you'd want the positive answer. Or you could find the vertex, and you could double the time, that negative b over 2a, and double the time. So I'm going to let you guys try this one. We want to figure out how long does it take to hit the ground. And you also want to find the vertex, the max height of the object. So that one you should try. And then there's two left. We'll do number 3, and again, number 4 is like the previous problems that we've done. So number 3, at what temperature will the bacteria be minimal if this is the function? And you can see right here that this would, the 20t squared is positive, so you would have something that maybe looks like this. Or maybe it, could look something like this too. But we want to figure out where the bacteria is minimal, or this point right here. And so again, that's the vertex. What will the number of bacteria be at that time? Okay, so let's do A first. Let's figure out the vertex. Let's do that negative b over 2a to find the x value, which would be the time. Actually, the temperature, because this is the temperature. So again, if we're looking at this graph right here, the dependent variable, and the independent variable is temp, and then the number of bacteria would be the dependent. Okay, so here is the temperature, negative b over 2a. Here b is 20, and it's the opposite of negative 20 or positive 20 over 2 times 20. So that would be 0.5 degrees Celsius. So this is temperature. At 0.5 degrees Celsius, the number of bacteria will be minimal. So then let's do b. What will the number of bacteria be at that time? So you're going to plug in your function. Number of bacteria at 0.5 degrees Celsius equals 20 times 0.5 squared minus 20 times 0.5 plus 120. Okay, so you're going to plug that in here. And if we do that, the number of bacteria at 0.5 degrees Celsius would be 115 bacteria. So for your assignment, I want you to go back and do number 2 and number 4 on this worksheet. And then we're just going to review a few more things, the methods for solving quadratics, and I'm going to assign a few more questions. Okay. So if we turn to the next page here. Three methods for solving quadratics. Directions: solve the following quadratic equation using all three methods. Make sure that you get the same answer after each method. So we'll do one of these together. I'll do one of these on your assignment. Or you'll do one of these for your assignment. Okay, so factoring is the box and circle. So this one here, pull out a greatest common factor, but there's none of 1, 6, and 7, so we're going to put it in the box and circle. We have x squared, we have 6x, we have negative 7. So we want two things that multiply to negative 7x squared that add to 6x. And so that would be 7x and negative 1x. So if we factor, we get x plus 7, x minus 1. And if we solve, we set this equal to 0 to find the roots of the function, or the 0. So x plus 7 times x minus 1 equals 0. Use zero product property. X equals negative 7 would make this 0. X equals 1 would make this one 0. So here are the two answers that you're going to get using any of the methods. All right, completing the square. You have the x squared plus 6x. Leave a space. Minus 7 equals 0. All right, so I'm going to put this in parentheses. We'll take our middle number, 6, divide by 2, and square it. So that would be plus 9. Oh, I forgot to leave a little space here. So if we're adding 9 here, we will subtract 9 here. Okay, so now we turn our trinomial to a binomial. 6 divided by 2 is 3. So we have x plus 3 squared would equal this trinomial. Minus 11 equals 0. And you could solve this function. You could add 11, take the square root, and so on. You could solve completing the square this way. This also tells us the vertex. The vertex would be negative 3, negative 11. Okay, and last one is quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac. Oops, should put that in parentheses. All over 2a. So you have x equals negative 6 plus or minus the square root, and that would be 36 minus 12, which would give us 24, all over 2, and then you could solve that, and you should get your two answers. Oh, that should be a 7, not 12. Okay, so minus 28. 36 minus 28 is 8, 18. Okay, so I made a mistake here. Let's fix this. This should be 18, not 24, because this was a 7. Okay. Oh, is that 8? 16. Yeah. Oh, just 8. Just 8. Okay, and then you would solve, and you would get your two answers this way. And it should match up. I'll have to double check that it should match up, though. All right, so I want you to try the three methods: factoring, completing the square, quadratic formula. So add this to your assignment. So far we have 3 problems for your assignment, 2, 4, and then this 2. And then let's look at one more type of problem. Okay. Right here, directions: choose the best method for solving each quadratic function. Verify your algebraic answer by graphing the associated function. Okay, so for this one, you get to choose the method you want to use. So the first one, we'd have x squared plus 5x equals 5. Let's put it into general form. X squared plus 5x minus 5 equals 0. Now that would be pretty tough to factor, and completing the square isn't as quick as quadratic formula. So this one I would use quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And let's solve that. X equals negative 5 plus or minus the square root. This would be 25 plus 20, so 45 all over 2. The simplest radical form, you would want to change square root of 45, pull out the biggest square number, which I think is 9. It's square root of 9, square root of 5. That's 3 square root of 5. So in simplest radical form, this is x equals negative 5 plus or minus 3 square root of 5 over 2. And then we would solve our two answers, and we would graph that. So let's do that. Let me grab my calculator. Sorry, my phone's ringing. I'm not going to answer it right now. All right, so negative 5 plus 3 square root, square root of 5. Okay, remember to hit enter before you divide, so I'll do that. Divided by 2. Okay, so one of my zeros, when we add the plus 3 square root of 5, is about, if I did this correctly, negative 16.8. And let's do it the other way where we do negative 5 minus 3 square root of 5. So negative 5 minus 3 square root of 5. Hit enter. And I'll divide that by 2. So about negative 5.9 if I round. So if we just sketch this function, let's say this is 5, negative 10, negative 15. One of the zeros would be at negative 16 point something. One would be at negative 5.9. It's a U-shaped graph, so this would be our sketch of our function. Okay, so I want you to try this. There's some more examples on the back. There's 2 more in the back, so I want you to try those. So your assignment then will be to try these 2, to go back and do, just go back here. This one right here, number 2, and then you have the 2 problems, number 2 and 4.